Hello and welcome to an interactive demo of Sophos UTM on Amazon's Elastic Computing Architecture. Today we're going to talk about Amazon Virtual Private Cloud. I'll spend just a few minutes explaining how VPC, or Virtual Private Cloud, is different than the Amazon EC2, or Elastic Computing Cloud, and then we're going to dive right into a live demo on how to architect and build some of the things we're talking about. At the end of this demo, you'll be able to launch a UTM within Amazon VPC, and then launch a machine behind it and access that machine from the internet. Let's have a look at some slides. So Amazon Web Services offers something called EC2. And if you haven't heard of this before, this is basically a flat network where different customers can launch machines. Now the downside to this is a lot of customers, especially looking at a UTM, try to figure out how they're going to launch a UTM and then have a concept of a network in front and a network behind, like with a traditional network firewall. The problem with this is that EC2 is a flat network. It's a large subnet provided by Amazon, available in different regions and different availability zones. However, there's no concept of machines in front and behind, and you can't make your own networks and your own subnets. So there is a chance you'll be on a different availability zone, launching next to other people and other customers who have their machines in that availability zone. And from there, it's going to get quite difficult to do some more advanced networking things. However, there is a much more powerful option. And once you get the basics of how it works, it isn't really all that complex. That's called Amazon VPC, or Virtual Private Cloud. Now, rather than have all of your machines just going to the outside internet and having basically a one-way communication, which does have some use cases for UTM, let's have a look at something much more powerful. In this case, I actually want to use what's called VPC, and I want to carve out my own little section of Amazon's excellent computing cloud and have the ability to do routing, firewalling, subnetting, and have a concept of a public and a private network. So what we can do is we can carve out our own little section here, which is designated as a VPC, and from there I can create some very powerful networks using my own subnets, using whatever IP addresses that I want. And while I might be on the same hardware and I might be shared in different regions, I have a lot more control over my routing and over my exact communications. And this is the way that you can use Amazon services to really create your own network. So let's look at what we're going to build today, and then we'll get right into it. It's actually a very simple setup. I want to create an Amazon VPC, and in that VPC I'm going to have a public subnet and a private subnet. Now, even within the VPC, my public addresses will be private IPs. Inside those private IPs, behind it, I'm going to add some Windows servers, and I'm going to launch a Sophos UTM using an AMI, or an Amazon Machine Image, which is going to sit between both the public subnet and the private subnet. And then from there, in order to make this accessible from the internet, we're going to create an elastic public IP, and we're going to attach that to the outside of our UTM. So we're going to jump into a live demo. We'll do it all in real time. Let's have a look at it. And now you can see that I'm sitting here at the Amazon Elastic Computing Cloud console, or the AWS, or Amazon Web Services. The one thing Amazon does have is they have a lot of acronyms, but that's because they have a lot of products. Now, the two things that we're going to work with today almost exclusively are Amazon EC2, which is where we launch our servers, and Amazon VPC, where we actually do our networking and routing and things like that. So to get started, we have to go to VPC. So I'm going to click on VPC. That's going to load in just a minute here. And from there, we're going to be able to create our own network. Today, I want to work with the Oregon region. Up here, you can pick whichever region might be closest to you, and Amazon is always adding new ones. This is a physical place where your resources will be located. So I've picked Oregon. And the first thing is I don't have a VPC. Now, I could do all of this by hand manually and clicking on individual things and setting them up, but their wizards are actually quite good, as is their documentation for almost everything. So let's use the wizard and see what happens. So we'll click Get Started, and now we have some options, and this is where customers tend to make some poor decisions because they're not exactly sure what they want to do. I won't spend too much time explaining them all, but I'll focus more on our use case for today. A VPC with a single public subnet basically gives us EC2. It gives us a single public available subnet that works through Amazon's firewall and Amazon's router, and that doesn't really differentiate us too much other than the fact that we're able to choose the IP scheme that works for us. There's also two options here at the bottom that give you access to these VPCs with a hardware backend, which of course our UTM does support, but will be covered in some different videos. Today we're going to talk about VPC with public and private subnets. And what's going to happen is when we're done, we're going to have a public subnet that's set up. a private subnet, and Amazon is actually going to launch their own NAT instance, which is responsible for doing the translation between the private and the public subnet. Well, because we actually want one of our Sophos UTMs to sit there, we're going to delete that NAT instance eventually, and we're going to replace it with a Sophos UTM. So first we have to build our IPs space and our networks so we can then launch things into it. So let's go ahead and pick this option. We'll hit continue. Now Amazon has suggested a little bit of networking here, which doesn't really mesh with what we want to do. So let's change this a little bit. And let's say that we want our network to be 192.168.80.0/22. And our public subnet is going to have to be something different than, of course, the 10 network, because that doesn't work, and they let us know that with some error codes. So our public-facing subnet will be 192.168.80.0/24, and we have to pick US West 2A. These availability zones by default are set to no preference, but because we eventually want to attach two different subnets to the same instance, our UTM instance, it is important that they are in the same availability zone, or you will have problems in trying to attach multiple interfaces. So what we're going to do is we're going to then start this one up again, and we're going to pick this as our public subnet, or private subnet, sorry, as 192.168.81.0, and we're also going to make sure that launches into 2A. If it does pick no preference or something else, it would cause us a problem later. So again, these must match. And the NAT instance, it's going to give us a small instant with no key pairs, and that's okay because we're going to actually delete it anyways, so we don't need to worry about that. As with all things wizard-wise, there's all sorts of little extra things we could say, but because this isn't really a detailed Amazon training, let's hit Create VPC, and we just have to wait a minute for it to fire up those subnets, allocate us the addresses, and basically carve out our own little piece of Amazon's Elastic Computing Cloud that will be only for us. Now once this completes, this can take up to a minute or two depending on the region that you've chosen, how busy their service is with creating other things, and where you are in the task list at the time. And it might take a little bit longer, so don't despair. If you need to, you can go get a cup of coffee and come back whenever this is done, and you'll be all set up and ready to go. Now it looks like it's all finished. So what we're going to do is we're now going to close this wizard, and you can see that before we had almost nothing, but now we have a whole bunch of things. It's created a VPC for us, it's created some subnets and some access control lists, and it's created a bunch of great things for us here. So the first thing that we want to do is we want to have a look and see what we've ended up with for subnets. So if on the left hand side we click subnets over here, we can see that there's our public subnet and there's our private subnet. Now this little dashboard is completely configurable. I actually might want to make some notes along the way, and I can use a pen and a paper, or I can actually just click the settings options, and you can see which things I really don't care about so much. So I don't care too much about the network ACL, for example, or if it's a default subnet, and I can hit close and certain things will disappear and move away. So you can do some neat things there. Now, the first thing that to notice is we can talk in different orders. We can talk about launching machines right now and come back and make it work, or we can preemptively set things up correctly and so that it will work. So what we're going to do first is we're actually going to launch two different machines, which won't work with the current setup that we have, and then we're going to come back and I'm going to explain how to fix it to make it all work correctly. The big thing to note with a VPC is that by default, Amazon doesn't know we have an excellent UTM product available that we want to use to bridge these two networks and basically act as the gateway. If you do read the VPC documentation, which is quite complete, the one thing to note is that the first 5 IPs or 4 IPs of every range are reserved for Amazon's use. So they will give you a DHCP server, a very simple port-based firewall, and in this case an instance which is performing NAT for us. So we can't allocate things with .1, .2, .3, .4. That's okay, we can work around that. So the first thing we're going to do is we're going to launch 2 instances. Let's go over to EC2 here and we'll get those launching, because that way some of the things that take a few minutes to actually happen so everything can be live can happen in the background while we come back and we adjust the networking and things like that. So first we go over to EC2, and this is where we can launch machines from. Now launching machines is actually really easy. You just click a button that says launch instance. But I'll take a little bit longer to explain some of the places where customers messing things up or making some very common use errors if they haven't been to a dedicated Amazon training before. So let's click launch instance. And the first thing it's going to ask is what kind of instance you like to launch. Now a lot of times people ask is they say how much will it cost? Well, VPC doesn't actually cost anything. However, what you launch in there does incur fees. So Amazon has their own pricing schedule and they put it all online, and you can explain that some things cost 2 cents a computing hour and some things cost $6 a computing hour, especially if you launch very, very large instances. So in this case, let's just pick the classic wizard because it has the most options and we get the chance to explain a few things along the way here. And let's hit continue. And now there's some default AMIs or AMIs. So we've done the work for you, and that our Sophos products are available and they're here under community AMIs. And all I'm going to do is I'm going to search for Sophos. So once we search through all of their AMIs, which there are quite a lot of, and you can see we have some different products here. We're going to choose this one, which is the UTM version 9.060, and I'm going to select that. And then I have some configuration options. The first thing is I could choose a micro instance, but that's going to give me a very low power 1-core instance, maybe 2 cores depending on what's available, and it's going to give me only 613 megs of memory. I want to launch something a little bit more powerful. So for today I'm going to launch a very simple medium instance. It gives me a dual CPU using 1 core, so I get 2 elastic computing units on 1 physical core, and it will allocate me 3.7 gigabytes of memory. It also works just fine in a small instance, and so we'll pick medium. And then this is where people do make a lot of mistakes, is that they launch it into EC2. We actually don't want to launch our machine into the Elastic Computing Cloud. We want to launch it into the Elastic Computing Cloud, but into our virtual private cloud, our VPC. So I'm going to choose that. And because I've already configured my VPC, it lets me know where I would like to launch this into. Well, we said at the beginning of our demo that we'd like to have a public interface of 80 and a private of 81. It really doesn't matter where you launch it, but I would recommend you launch it into the public side because of the way the Sophos UTM pulls interfaces. It expects that the very first interface that it fires up with will be the internet or the external facing interface. So what we're going to do is we're going to launch it into that one, and that way we don't have to reconfigure the interfaces later. So because 80.0 is my internet or my public facing network, I'm going to launch my UTM in that, and then I'm going to add the private one as Ethernet 1. So once I've picked that, I just hit continue, and now I have the ability to configure a little bit more options. So if you read some of our documentation in this user data field, I could actually paste in things that would cause the UTM to automatically load its backup file or automatically create the initial user configuration, things like that. I'm not going to worry about any of these options except for down here in the networking part, because this is the important part. So by default, it's going to pull its own address from that subnet, but because I want to know what it is for later, I'm actually going to assign it one. So I'm going to say it's 192.168.80.5. Again, we can't use the first few IPs because they're being used. And I'm going to add a second interface. Now this is also important. We get a lot of questions on this. In EC2, you can only have one interface. In VPC, you can have more than that, and the number of available network interfaces is defined by Amazon and is linked to the size of the instance that you spawn. So it's not possible to have like a medium-sized instance like this with 8 network interfaces. That's something that they choose on their side and they dictate, and so we're just going to work with that by having a simple 2 network setup today. And then I'm going to click on Ethernet 1 here, and I'm going to launch this. This is very important. We need to change this and make this the private range. And just again, so I know what that is, I'm going to say it's 192.168.81.5. So 80.5 is the public IP on the UTM, and 81.5 will be the private IP on the UTM. And so we'll hit continue. And now it gives us a little bit of information about the disk that it's going to make. Well, the default size is actually 30 gigabytes, and we want to make that a bit bigger. So I'm going to edit this. I'm not going to worry too much about the options in here, but I'm going to change this to 120 gigabyte disk. And if I want, I can choose to incur a little bit more usage fees and have a dedicated input-output operations per second and basically make the hard drive much faster if I want. But I don't need to do that because their standard stuff is actually quite fast for what you get. And as with a lot of things inside the computing cloud, you do pay more if you want things reserved or specially purposed to you, rather than drawing on the collective availability of things as a whole. So let's just hit save. Make sure you hit save or it doesn't work. You see that size now jumps to 120. I'm happy with that. And now this here is simply text tagging. And I do want to make some text tagging, so let's call this our VPC UTM. And we'll just give it, I'm just going to put something in here like the address public. And the address public is 192.168.80.5. And I'll put address private. Just so I can later on get some visual cues on things from the dashboard. You can do whatever you want there. You can tag it with owners or keys or all sorts of things, whatever you like. And we hit continue. Now we have a couple of other things where people tend to get confused. Amazon has the ability to log into things using public and private key files. However, because the UTM does have command line access available using SSH, if we turn that on, we could use those key files if we wanted to simplify things or for a bit of extra security, but we don't need to do that today. So here for a UTM, it is perfectly fine to proceed without a key pair. You cannot do that for other types of instances in some places, which I'll get to in a bit, but for today, proceed without a key pair. We hit continue, and now we're at the part where we can configure a firewall. Well, now the UTM is going to be launched into a private network, which is basically NAT, or able to see the internet through an internet gateway and through an attached elastic IP address. However, because the UTM is a firewall, we don't need to have a firewall behind a firewall taking ports away from us and things that we need to accommodate twice. So I'm going to create a new security group, and I'm just going to call this fully open. And I'm just going to say this allows all traffic. And from the drop-down list, I'm going to pick all traffic, which is basically everything. I'm going to add the rule to the table, and I'm going to hit continue. And that way I don't have a firewall sitting in front of my firewall. And so now I look at this, I have a VPC ID, I have a subnet, I have some availability zone information. I have a look at it and make sure that we have a primary network interface, 192.168.80.5. We have a secondary network interface, which is 192.168.81.5, no key pair, and our own security group. If anything here looks wrong, you can just go back and edit it. If you're happy, you hit launch. And if you haven't made any mistakes, you'll get a success page like this, and we just hit close. Now this is just going to take a second for it to launch. And now that we're at the EC2 page, you can see we have our VPC UTM, and we also have ourselves an Amazon NAT instance. This was created when we built our VPC. This isn't made all the time, only if you pick the VPC with public and private subnets that we chose when we launched our VPC. And you can say what it's done is it actually has allocated a public IP address and has sent that through to the NAT instance at 192.168.80.15. So the NAT instance has an IP in that subnet, and it already has an elastic IP allocated. So we're not actually going to use any of that, but we will repurpose this address. We could grab another one, but we might as well just steal the one that they've used and bring it over here, and we'll have a look at how to do that in just a second. Because these machines take a minute to fire up and be actually available to be used by us, I'm also going to launch our Windows machine into the private network right now, and so that way it has a few minutes to fire up and fully come online so we can actually use it later in the demo. So let's launch our EC2 instance for Windows. I'm going to click launch. I'm going to go to the classic wizard again, and this time I don't need to go back to the community page, so I'm going to jump back to the quick start page, and I'm going to find a Windows 2008 server. Just a base one will do today. And I'm going to hit select. Let's make this another medium style instance, or actually we can even make it small because we don't need to make too much information available. We're not going to use it for too much today in the demo. And now we're going to launch it again into VPC, and we're going to launch it into the private space, which is not technically available on the internet, so to speak. This is our private network as per our architectural diagram. So we're going to pick that and hit continue. And now again, we don't have to mess with anything here, and it only needs one interface. It only needs to be plugged into the private setting. And right now, I'm going to give it its own IP address of 192.168. Let's give it 81.10, for example. And then we'll just hit continue. We also want a little bit more size because it is a Windows machine. So let's just give it 60 gigabytes of disk space. Hit save to make sure the change is effective, and we'll hit continue. And again, I'm going to call this now, this is our VPC Windows server. And we could give it an address, something like the private address, or the private IP. I think we called it private address. Doesn't matter, we can always change the tags later. And I'll say this is going to be 192.168.81.5. Now they have their own tagging system and there's their own columns available, but I don't mind having a few for myself. It's very common for if you're sharing accounts, you might say this is owner and put my name in there like Angelo, or I could put something like purpose. And maybe this is our Minecraft server or something like that. You never know what you want to do with the machines that you're hosting in Amazon's cloud. And so the tags are just text labels. They have no effect on anything and no real physical bearing on the operation of the machines. So we hit continue. And now, when you are launching a Windows server inside Amazon's cloud, you need a key pair. And if you don't have one of those, you're not going to be able to access this machine. So let's create a key pair. I don't have one already. So let's just call this Angelo's key. And then I'm going to create and download it. And it's going to ask me where I want to save that. I'll just save it to my desktop here as Angelo Key and hit save. And now we have a key file downloaded. So we'll use that a little bit later. And now by default, here's Amazon's firewall getting in here again, and it says even though I'm launching it into a private network, it's going to give it a quick start security group. It's asking me, it's recognized that I've launched a Windows machine, and it says I'm going to give you a firewall that's going to only allow port 3389 through it. Well, again, we're going to place this Windows box behind our excellent and very secure UTM, so we don't need it to have another firewall in addition to the Windows firewall and our firewall on the UTM. So I'm going to go back to my existing security group, and I'm just going to open this fully up for all ports. And so that way some port-based firewall on Amazon's side doesn't get in the way of my testing, and everything I do on the UTM I can take as fully granted and ensure that that traffic is going exactly where I want it to. So I've already made the fully open group, but I'll just reuse it again. Have a quick look to make sure all of this looks correct. I'm happy with that. We're going to launch a Windows server into our private network. It'll have an 81.10 address, and we have a key pair here called Angelo Key, and I'll hit launch. We've done it right, no error messages, and so now it's closing. So this is now going to launch here, and it's going to say pending. Now what a lot of people try to do and they run into once in a while is they try to retrieve the admin password, because when I remote desktop to this machine, you'll notice at no point yet have I made an actual admin password for my Windows box. We'll get to that in a minute, but basically you need about 10 or 15 minutes for Amazon to fully bring this machine online before the password is available. So if you try to do it too early and you right click here, and once it's actually launched up, this will become unchecked or unbolded, sorry, and you're actually able to pick on it, and it'll say get Windows password. And if I just do it again now that it's running, you'll see that it says please allow a little bit of time for the password generation to actually occur. So we just have to actually leave this thing running for a bit, and it's just a one-time thing when you start a new instance. You just have to wait a little while for the instance itself to be fully created, and then they'll give you your password. So we have our UTM running inside our VPC, which is attached to two networks. We have our Windows server, which is attached to our private network. And now we can do some basic setup information. So the first problem is that I need to be able to reach my VPC UTM. And so if I click on it, I get a status page. And as you scroll down here, you'll see that it has a private DNS. So I can't type that in and get to our web admin. I can't type in eus.compute.internal. So what I need it to have a public way of being reached. So we're going to do that using an elastic IP. So I'm going to click over here to elastic IPs. And you can see that it's already allocated one. It says this address has been allocated. They give it a public host name. And what that is our NAT instance provided by Amazon. So let's see if we can just reuse this address by dissociating it. And it says, are you sure you want to release it? Yes. So I still own the address. It's still carved out for me. But now I just want to associate it to something else. So let's go ahead and associate the address. And now I can pick an instance. And so because I was smart and I tagged them with a little bit of a name, I see more than just the instance ID, which is the default. So there's my VPC UTM. And now I can choose, and you can see that it defaulted to picking the 81.5. And if I hit associate, it's going to associate it to our backend network, which I don't want. I want to associate it to our public-facing network. So I'm going to pick 80.5, and I'm going to hit associate. Now in just a second, it's going to give us up. It's going to host. It's going to swap that over to that instance, and it's going to say, there you go, there is your public host name. So if I've done this right and I've not messed anything up, if I go to a new tab and I just type in HTTPS and I fill that in and I go to port 4444, I should end up on the UTM, which I have. So we get an error because, of course, the UTM is handing out its own CA certificate to the browser, and I haven't trusted this new UTM in my browser yet, so I just proceed anyways. And because I've never been to this UTM before, I'm going to have to do a little bit of basic setup in order to make it work with our Amazon network. So let's go ahead and do that. It doesn't take very long. Now we can give it a host name. We can give it this long Amazon host name, but if you have your own DNS hosting service, you might actually want to make this something else much shorter and then use a CNAME alias to alias to it, which is what I do. So this could end up something like vpc.yourcompany.com, for example. Because I don't want to edit DNS records and do that in this demo today, I'm actually just going to paste in the Amazon hostname they were nice enough to give us, which is this nice big long one here. And I'm going to say this is belonging to Sophos. I'm in Vancouver, British Columbia, for example, and that's in Canada. And we'll give it a password and an address to talk to if it needs something. I don't think this is being used, but just in case it is, I'll actually make a big long random string in there. And then we're going to hit accept, and we're going to perform a basic system setup. Now what happens now is it takes about 40 seconds for the CAs to be created, and this is basically introductory setup to UTM. And so this isn't really designed as a UTM training course. If you've set up UTM in the past, You know how to get going with it and set up public and private interfaces and things like that. However, we are going to make a few little changes here in order to make everything look a lot more smooth and run a lot better here. I didn't want to have to set up things ahead of time behind the scenes, and so that way you were wondering what exactly it is was happening when you weren't watching. And so we'll do everything live, but that'll require us to massage a few things here just to make it look perfectly. Let's hit proceed anyways now that we're back. Just takes a second, and now we can log into the UTM, and now here we are inside our UTM, which is running in Amazon's very powerful elastic computing cloud. Sure, we'd like to help make UTM better, why not? And you can see there's our CPU power, we have 3.8 gigs of RAM, and by default when you fire this up, we have a 30-day license ID. So I've fired this up using the bring your own license model, which is you do need to contact your partner or salesperson and put your own license in there. Otherwise, you'll only have a few days of functionality before things start to require license keys. But that's enough for our purposes for today. Now, one of the things that we will fix is by default under interfaces and routing, we actually want to plug in both interfaces into the UTM, into the network. However, our interface here has been labeled internal. Now, I could just work around this with naming, but I don't want to get us confused later on. This is actually our external or public facing side. Now, for your protection, because if you do change this interface type, you can lock yourself completely out of the instance and have no way back into it. So we took some command line steps to actually lock this interface and make it so that you weren't able to change the type of it. We are going to give a bit more power to our users in the next release that's coming up very quickly here and make it so you are able to edit Amazon instances if you like. So in order to get to the command line so I'm able to remove this lock and change this, I'm actually just going to go to definitions and users here. To management, system settings, and I'm going to change a few things along the way, such as let's change the time and date to the host name that this is actually in, which is the Pacific Zone. And we're actually going to change the time to be correct, which is actually 1:03 in the afternoon. And we'll just hit apply up here and apply down here. And then we want to turn on our shell access. Now our shell access, it's just going to take a little bit of lag here because since we've reset the system clock, depending on which way you move the time, you might get logged out of the system and have to log back in. Sometimes it's smart and can recover for you, so we'll just give it a second and see if it gives us back there. Otherwise, we'll just go ahead and log back in again. Now that the clock is reset, we can actually log right back into our instance again. Just takes a few seconds. We're going to be able to get in there, and that way we can then work with a few things that we need to do, such as turning on the command line access, just because I want to relabel this interface for the demo really quickly. So let's go ahead and go to management. We'll go to system settings. I'm going to turn on the shell access, and you definitely don't want to leave this available to any because it's going to be in Amazon's IP space, and there's going to be all sorts of bots and things that are going to try to log in as root, even though they can't. But I'm going to turn it on very quickly just for a little bit. I'm going to set my passwords ahead of time to be something super secure so that we don't have to worry about some bot trying to log in. And of course, when you do try to log into the command line of a UTM, you can't log in as root anyways. You have to log in as login user and super user up to root. This demo isn't really designed as a command line tutorial, but I do want to rename that interface. So I'm going to do that quite quickly by turning on our shell access here. I'm going to cut and paste our host name out of the title bar here so I'm able to SSH to it with a command program like putty. And I'm going to connect to that. And if we've done everything right, I'm going to quickly be able to get into the command line here. Head up to root, and I'm actually just going to do a very, very quick command that's going to allow me to unlock that interface, and so that way I'm able to relabel it. So I'm just going to go ahead and paste that in here. Hit enter, and that's all we have to do. It's now unlocked, and I can close the command line interface, and I can disable my shell access or limit it later on to only my own private range or something like that. So now that we're done that, we can actually have a look at what's available. So in the default installation, it's going to be able to get to the internet, and we have to do some natting and some masquerading. But the first thing I want to do is I want to change this interface name and add the other interface. So let's go here. We're going to edit it because now the buttons are available. We're going to call this external, and we're going to hit save. It's also very important that you do not change the interface type, but I will change the comment, and I will say this is the public facing network. And we'll hit save. And rather than create it all from scratch, I'm just going to hit the clone button, which fills in a few things for us. I'm going to call this internal. And for the internal side, I could type the IP address out by default because we've assigned it anyways in the Amazon side of things on the Amazon machine, which is powering the UTM. So if I leave it as DHCP, Amazon's DHCP server is going to hand that out to me. Their DHCP server is always going to be running unless I do want to shut it off. But let's configure it manually anyway. So I'm going to pick an Ethernet static. And I'm going to say this address is going to be 192.168.81.10 is what we allocated, or sorry, 81.5 is what we gave it during the setup. If you do want to check it, we come back here, we go to EC2, and we just make sure our addressing is correct. So I can actually look at my instances here, and I can pick the Amazon UTM image that I had. And down here it shows me the addresses, and so I can see that 80.5 is the outside one. And when I allocated the interfaces, if I actually click Ethernet 1, it'll show me the other address, which is 81.5. So that's correct. So let's go ahead and do that. We'll leave it 81.5, and we're just going to change the text here to call this the private-facing network. And we'll call that internal, and we'll hit save. And we'll just make sure that we actually turn this interface on. And if we just refresh one time, it comes up very, very quickly. We now have two networks. Well, our Windows machine, which is sitting in that 81 network and patiently awaiting us to get to it, is going to need a little bit more work before it can actually use the UTM as a gateway. Not much, but rather than run through a wizard or something, we'll set it up manually. Let's just go ahead to Network Services, and we're going to set up our DNS correctly. So let's go ahead and drag our internal network in there. We'll remove the default, which was the outside one. We want our Windows machine to be able to use the UTM as its DNS server. And that's rather than use the Amazon DNS servers themselves, which they have one sitting at 80.2, which they automatically do for us as a nice gesture. Let's go ahead and add our own. We'll use the Google DNS servers today, and those are at 8888. We'll hit add that. And we'll add one more, and we'll call this Google DNS 2. And we'll say that's at 8.8.4.4. We'll add that, and we'll uncheck this little box that requires us to use the ISP forwarders, and we'll hit apply. So we now have our own couple of forwarders in there. We've allowed the internal network to make use of this system. And let's continue along with the network stuff that we need to do. Really quickly, we should go to NAT, and we're going to make a masquerading rule. We want to make sure our internal network is masqueraded to the external IP address. So I'll do that, and I'll hit save. And again, make sure you actually turn those rules on. They stay disabled until you enable them as the admin. We'll come back here in just a little bit when we're doing our remote desktop stuff. And lastly, I need a firewall rule. Because I'm not too concerned with security today, I'm just going to allow all traffic from the private network to go to the internet. So I'm just going to say the internal network going to anywhere is allowed on any service. And that's, of course, is stateful. So if we then come in on remote desktop and we punch a hole through the UTM for remote desktop, the traffic in return is automatically allowed. We don't really have to accommodate the packet filter for that, but we'd like our Windows box to be able to get things like updates and things like that as well. So even though it's protected by a firewall, we don't want to impede its outgoing traffic. And I'll just say this is allow all outgoing. Depending on where you come from in your security background, you might find this a very bad idea, or you might do exactly this in your own networking. So we've basically set up two interfaces. We've done some masquerading or some NAT between them. We've enabled our DNS proxy and allowed the internal network to make use of the DNS services, and we've made a firewall rule. So now if we look at it here from the dashboard, we can see that because our UTM is so helpfully connected itself to the internet, it has noticed that there is some updates available. I could perform those updates, but it'll take a few minutes. The firewall will reboot during that time. And rather than actually do that while it's downloading and making these updates ready for installation, we'll just assume that when you do install your UTM, one of the first things you do want to do is actually update your box to the latest version. And you can also replace your license key with your own licensing right here from licensing. So you can put your own key in here itself, which gives you access to the various features that you need on your UTM. So by doing nothing else just yet, I'm also going to enable our web protection so we can actually look at some log files a little bit later. Let's turn that on. I'm going to allow our internal network to make use of our web filter. And again, I could be quite specific here and spend a lot of time configuring this, but I'm just going to leave the antivirus and anti-malware on, and I'm going to enable a very quick pornography and nudity filter that we can test a little bit later. Now, so we've got our everything set up, but we do need to be able to reach our Windows machine. So in order to do that, we have to go here to interfaces to network protection, and we want to go to NAT, and we now want to make a port forwarding rule that sends traffic from our outside IP address to our Windows machine. So we're going to go to NAT. We're going to make a new NAT rule here, and this new NAT rule is going to say traffic coming from anywhere on the service remote desktop. So rather than look through the list, I'll just type in remote, and I can drag in the pre-existing Microsoft Remote Desktop service, which is to port 3389, which is what we want. And we're going to say this traffic is going to land on our external address. That's where the traffic's as far as it's going to be able to get. We'll trigger a match based on that, and we're now going to change the destination to our Windows server, which doesn't exist on the list. So let's just click the little plus sign here. We're going to call this the VPC Windows Server. And it's a host, and it's sitting at 192 192.168.81.10. And the comment is our VPC private Windows server. And we'll hit save. So that's all set up. We now have a port forward rule. Oh, and we don't want to make our own firewall rules for that. We could, let's just edit that one more time. We're going to go to automatic firewall rules. And just for testing purposes, I'm going to tell it to log the very initial packet, just so I can show you where a lot of people go wrong as they're setting this stuff up. So we're going to hit save. We're going to turn that rule on. And now you'd think, oh, this will be great. Now I can see my Windows server. So this is where a lot of people then start to make mistakes, because they've set things up the way they know how to do it with UTM. They've launched their public and private networks in the VPC, and they've got everything set up for a public IP on their UTM private IP, and they come down here to maybe the support tools section. And here they do a ping check, and they say, let's have a look at our VPC Windows server, and hit apply. And let's just run a quick ping check and see if we get any pings back, because that's usually the first test that network admins do. So if we've done this right and our Windows server is actually on, it should respond to a ping. Our public facing, or our UTM that's sitting in a public and private network, is able to ping our Windows server. Fantastic. I should now be able to remote desktop to it. So they pull this up, and then they grab the host name out of here like this, and they do that. We'll just cut and paste it for brevity's sake, and we hit connect. And what happens is it doesn't connect. And so if you know a little bit about troubleshooting in UTM, we'll have a look at a log file and see, oh, is the traffic actually happening? What's going on? So let's go over here to network protection and to NAT, and we'll just open the live log here for the firewall. Oops, we don't want the fallback message one. Let's just hover here and we'll grab the firewall log. And we've received an error on our remote desktop. So what's going on? So let's try it again, hit and connect. And oh, we get an entry right away that says, well, the traffic has come in from the outside and has ended up on the outside facing the 80.5 address, and it just never comes back. And the reason for that is actually quite simple. We're going to have to leave our UTM. We won't change anything else on this because our setup is actually correct, but we have to finish replacing Amazon's router on our virtual private cloud. So let's jump back here, and we're going to jump back into VPC. And here's where you have to make a few more advanced settings, because by default, unless you're a UTM company like us, one of the things you don't need to do is usually replace all the Amazon NAT router. So what's happening is the traffic is getting through the UTM and going to the Windows machine, who is then responding out of its default gateway, which is not the UTM. There's actually routes and stuff in place that are getting in our way, so we have to disable that stuff. So the first thing is, let's go to the route table and have a look at what's happening with routing. You can see that by default, they have two different routes, and the routes are associated with different subnets. So the first thing to check is what subnets are associated. So let's have a look at the non-main routing table. And we can see again the same thing. It treats all of our private space that we've set up as local, and it sends everything else to the internet gateway. Amazon has given us an internet gateway, which we've then mapped an elastic IP to. We don't want to mess with that. We need to be able to get this 192.168.80.0/24 to the internet through the internet gateway. And so if you check the associations, it says this is associated only with the 80.0/24, our public facing network that we wanted. So this is actually right. The problem here is with the private facing network. And it looks like it says, okay, well, it has the same kind of thing, but however, it's sending something somewhere else. It's sending everything to an image and an interface. And if you look at the associations, it says the following subnets are not associated with anything specifically, and so they are therefore using the main routing table. We can see that this is in fact the main routing table, and so that means that everything in 192.168.81.0 is being sent, if it's not local traffic, to whatever this is. So let's have a look and see what that is. We do that by actually going to EC2, and I saw that that interface ended in AA. So let's have a look at our network interfaces. And we can see that what's happened is that is actually being sent to the network interface that ends in AA, which is right here. And actually this machine, this is our 80.15 machine, and this is that Amazon instance that they assigned us for NAT. So this is their setup that they are using by default, which works fine. However, as a UTM company, we actually want to use our UTM. So we do not want to route all traffic by default from our private subnet to this NAT instance. That wouldn't work so well. So instead what we want to do is we want to find our UTM on here. Now some of the labeling is a little bit challenged sometimes, so we just have to be sure that we know our IP addressing. Here is our UTM right here. It's our public facing interface. Well, we don't want to route internal traffic to that. We want to route it to the internal side of our UTM to 192.168.81.5. And so because I can't label this terribly specific, I'm just going to have a look at my network interface ID here. and I can see that this network interface ID, it actually is in use, and it's attached to instance number 628, and just by coincidence, this interface ID actually ends in alpha alpha as well. And we want to route it to interface alpha alpha, and rather than remember the whole number. You can write it down, cut and paste it if you want. So let's go back to EC2 or to VPC, sorry, and change our default route for our private network so things work as we expect. So then we come here, we go to our route tables, and we're going to edit this routing table here, which was the main route table. And I'm just going to make an edit here. So I'm going to remove this one because I don't want that. Let's just double check it. You can see it's routed to this instance and this interface. So let's delete that. And what we're going to do now is we're going to make our own route. We could just make a new route table, I guess, and associate it that way. But again, different admins will do things different ways. Now the target. I want to actually enter my network interface ID. And it's going to say, which interface ID would you like to use? Now, just by the luck of the draw, we have an interface that ends in AA. But be careful here, because if you were to pick an instance, we also have an instance that ends in AA. Now, the instance is our NAT instance. We don't want to route traffic to our NAT instance. We want to route it to our UTM instance. And we actually want to route it to a very specific network interface, which just by sheer luck, again, happened to also end in AA. You can't really change these. So we hit OK. And if we've done that right and we click Add, it's going to say, are you sure you want to do that? Yes. And you can see the resulting instance there is this interface, 3 alpha alpha, which is running on the instance B628. Now, you think this is okay and we're all set up and we're ready to go. And so what we do is we go back to our Windows server and we say, well, we've disabled the Amazon routing, which is sending all of our traffic to their NAT instance, and we've set things up correctly here, so we should be able to hit connect and get in. However, we're still not able to make a connection. Even though our firewall log is showing us, yep, there's some NAT rules and things are progressing along here, we're still not getting a response back. And now, even though our traffic is being routed correctly, there is something we need to disable. And if you're not paying attention, this is the part to get a pencil, because this can save you hours of work. Amazon, in their EC2, I'll just look at this tab here under Network Interfaces, has a built-in thing called source and destination checking. And you'll notice that it's off on their NAT instance. And we also need to turn this off. And this is where people also make mistakes. They forget to do this, and if you are wanting to act as a NAT instance, and the instance that you're using as a router, of course, isn't creating all the traffic, it's just passing it along. So we need to shut this off. However, what they often do is they go to instances, and they find their NAT instance or their UTM, and they right-click and they hit change source destination check. There's lots of tutorials on the internet that do this as well. The problem with this is that this shuts this off only on the public. You'll notice this doesn't end in 3AA like our internal interface. This only shuts it off on the public interface. That's not going to solve our problem because our Windows server is in our private network. So to do that, we're actually going to go to network interfaces themselves. We're going to find our one here that ends in the one that we need here. We'll just drop it down. And we need to find our internal one, which is associated to that particular one, which is the 81.5. This is the private style address on our UTM. So I'm going to right click there and I'm going to hit change source destination check. And I'm going to hit disable and I'm going to click save. So now what's happened is I've routed around the Amazon router, routing the traffic to the 81.5 address of the UTM. And on the network interface for 81.5, I've disabled the Amazon source destination checking. So if I've done this correctly, I should now be able to connect, and right away I get prompted for credentials. And you think, yeah, I can log in as administrator. We've done it all right. Everything is perfect and we're almost finished. And what's the password? Well, if you remember at the beginning of the demo when we launched our instance, there was a way that we could retrieve our Windows network password. So let's go ahead and get that. So we'll go back to instances here. And on our VPC Windows server, I'm going to right click and hit please give me my Windows password. And now we need to use that key file where at the beginning of the demo I made a key, I called it Angelo Key, and grab angelokey.pem, hit open, and we can now decrypt the Windows password. So this is the password that they've generated for us. We can change that later, of course, with our excellent Windows administration skills. We hit close, we go back here, we click that, log in, and you can see now that in just a second we're actually going to get remote desktop to an Amazon hosted Windows server in a private IP range behind a UTM, which is using the UTM as its gateway. I'll just pop that up here and open up on the other monitor that we have, so I'll bring that over here. It's going to prepare our desktop, and life is good. So let's have a look at network and go to properties here. And you can see that our IP information, actually I just want to drop the command line, I can show you from there as well, just a little bit easier. And you can see that the address they gave us here is 192.168.81.1 and the DHCP server of 81.1. So we could replace that with our own DHCP server if we want. So it's pulled the address from Amazon. And you can see that even though we've assigned an address, it's given us not an address of 81.1, but a gateway of 81.1, a DHCP server of 81.1, and a DNS server of 80.2. We've told an Amazon router that it's going to grab all of the traffic and route it to the UTM. This poor Windows machine still thinks that the Amazon instance or the router is its default gateway. So perhaps I actually want to change that myself. And to do that, I'm going to change it and so that I could make a DHCP server on the UTM and cause it to hand it out and disable the Amazon one. I could do that. I can simply just change the IP on this particular box to match the IP that I've given it in Amazon, but tell it to use the gateway and DNS on the UTM. And I'll do that really quickly as well. So if I come down here to the Start menu and I go to Networking, can have a look here, open the Network and Sharing Center. And what I want to do is I actually want to change our interface here. So let's have a look at our networking connections. Here it is here. Right click and hit Properties. And of course, under IPv4, it's all going to be automatic. And so let's just replace everything here and say this is going to be 192.168.81.10. And it's going to use 192.168.81.5 as its gateway and 192.168.81.5 for its DNS server. So if we've done that correctly, we've now changed the gateway. Of course, we're going to get disconnected from this machine. I don't think it's going to be able to recover our remote desktop session because we've now just changed its gateway. So we'll just give it a second and we'll close the window here once Windows decides to let us time out. And in the meantime, I'll just quickly review what we've done is that we've now launched our VPC UTM. It has a public and a private subnet. We did attach an elastic IP to that, so we're able to see it. Amazon also gave us a host name that we've been using for a lot of our communications today here, which is this host name down here. We've downloaded a key file. We've made sure that we're using a fully open security group, so there's no Amazon firewall getting in the way there. And then what we've done is we've changed some routing in the VPC routing section. So we've came here to the route tables, and we've edited the main routing table, which was not associated with anything, and so that way our private network was being associated with it anyways. We've changed the route table to make sure that it points at the internal interface on our UTM so that we're able to get to the Windows machine itself. But if you follow this guide, at the end of the day, you're able to launch Windows machines inside that private network, or Linux machines, or web servers. You can come into the UTM itself and you can protect them with port forwarding rules. You can create web application firewalls. You can turn on intrusion prevention and apply IDS traffic to it. And basically you can run your UTM as the gateway in a VPC and have machines living behind it. Let's quickly just jump back to our machine, which should be back now that we've changed the gateway and everything like that. We'll put that really complex password back in, and we can go ahead and we can end up right back where we started. Now, one of the things with Amazon is that, of course, being Windows Server, it's going to have Internet Explorer protected mode enabled by default, so you're not able to quickly just fire it up and then with our nudity filter that we turned on, attempt to test to something like playboy.com. But just to show you that we are surfing through it, we're actually just going to hit use recommended settings for today and hit OK, and we'll just make a whole bunch of exceptions as we do it. So if I now type in playboy.com, it's probably going to say that this is currently being blocked or whatever, so let's just go ahead and add it for right now, just so we can do a test. And we'll add the pass-through.firewallnotified.net as well. And because we've enabled the pornography filter on our UTM, you can see that this particular Windows machine has accessed the internet, has accessed playboy.com, and it's not able to work. So everything seems to work just fine. Life is good. And I do appreciate you taking the time to have a look at it. So we've launched a UTM inside it. We've disabled the Amazon router and replaced the Amazon NAT instance. And just to finish everything up, we're actually able to come back here to our EC2 management. And let's go ahead and terminate the Amazon NAT instance because we don't need that anymore. So we're going to go ahead and terminate that. We'll delete the storage for it and hit delete. And now at the end of the day, once this is finished shutting down, we can look at running instance types. And we have a VPC UTM and a VPC Windows server. Thanks for paying attention. If you like this video, I'd invite you to try some of the other ones that we have coming very shortly as well, covering different aspects of using UTM within Amazon's Elastic Computing Cloud. My name is Angelo Comazzetto, and thanks for watching.